Hello, everybody. Hopefully, you are doing great. Now, we are going to talk about a very interesting topic that is about projectile motion. So, let me start with the first thing, that is, what is a projectile? In understanding, a projectile is any object that you initially push in the air and it travel into the dimension. For example, if you have kicked a football, for example, this is a football, and you kicked it from this side, and you are providing it some initial push. So let's say the initial velocity you provided is VO, and this football, after you kicked, is moving in the air. But when you see it will get into the air, it will not only move upward as well as it will go forward, and it may reach the ground at this point. So this type of motion that is having two-dimensional path, we name this a projectile. So in this projectile, the path it is followed is called trajectory. So this is trajectory that it is following. It is the path followed by the projectile. So we can say the football is actually the projectile, this kicked football. So this soccer ball is your projectile that is initially pushed at some angle, let's say theta. Keep it in your mind that this theta has a special characteristic, that theta should be between 0 to 90 degree. So we can just simply say that the value of the theta is in between 0 to 90 degree. So theta is less than 90 degree but is more than 0 degree, because 0 degree mean it will only move horizontal, 90 degree it will move forward. So if your angle is between 0 to 90, so this projectile will move forward and uh, upward as well as downward. So this football that was kicked at some initial angle between 0 to 90, and it was initially having initial velocity v naught, it has two-dimensional motion, so we call it football. Similarly, when you throw a basketball toward the basket, it also travels in the same way. A cannon shell also moves in this way. So all the objects that move in two dimension under the gravity are named as projectile. When we are talking about projectile, so I need to write its simple definition that I can. So we can say if an object is initially pushed into the air, so uh, object pushed in air, object pushed in air travels in two dimension. When I use word two dimension, it means I am talking about horizontal and vertical, mean forward as well as up and down. It's going forward and also it is going up and down. So two-dimensional motion under the action of gravity. That object is projectile, and the path it is following, that I named trajectory, is in math you can say this is parabolic path. So this is parabolic path. The trajectory is parabolic in nature. Okay, when we are talking about this parabolic path of the projectile, we also need to talk about another thing, some properties of the projectile. A very important properties of projectile that we need to remember. For example, this is the kicked football that we initially kick here. This is the same football that we kicked. Okay, it was on the ground. I initially kicked this football with some initial velocity V naught at which is making angle theta, for example, with the horizontal. So initially when it was having Vx naught, so as I told you earlier on, it will follow a parabolic path. Let me try to show its parabolic path like this one. So this parabolic path, and it will hit the ground. So I just need to understand its motion. So let me have few points here. The position with the time. This is the initial position. After some time, this football may reach here. And here I will name its velocity, maybe let's say V. When it will reach at the maximum height, it may have the velocity, and at this point will be here. When it is at this spot, its velocity may be on this position, and before it hits the ground, its velocity will be in this direction. Now this projectile, when we hit, it is moving horizontally, and horizontal distance it is covering. For example, horizontal distance I mentioned from this position to this position, and this horizontal distance is because of this velocity have two components. So if we ignore the air resistance, this velocity's two components are like this velocity has initial horizontal component v naught x, and this initial horizontal component, because there is no acceleration horizontally, so at some time t, it vx will become remain similar. So Vx is equal to V naught x, but when it reach at maximum height, it will again be Vx, but it will still be same. Similarly, when it will reach here, so this will be here, and when it is going to hit the ground, this will be here. So keep it in your mind that first important property is Vx remains constant, that horizontal component of the velocity remains constant as it was initially v naught x. So it will be throughout the journey, vx will be equal to v naught x. As it is remaining constant, no change in horizontal velocity, so we can say that there is no horizontal acceleration. So we will say there is no horizontal acceleration by any mean. So I will say there is no horizontal acceleration. So if acceleration is denoted by A, so I will say horizontal acceleration AX is zero in the journey. Okay, on the other hand, if I try to show you the vertical components, let's say initially its vertical component was V naught Y. As it goes up, this V naught Y start reducing because it's purely purely behave like when you throw something upward. So this upward motion make it reduce, and the ball, for example, you throw upward, it will slow down, slow down, slow down, and when it will reach at maximum height, it will stop. So here at this point, its initial velocity was v naught y, and then it start decreasing to vy, and when it reaches the maximum height, so vy here will be zero. So it means at the top, its total velocity is only vx, vy is zero. But as it start moving downward, so vertical component of the velocity changes the direction and it goes to downward direction vy, and it is as going down, its speed goes on increasing. So here I need to mention one more thing, that as the object is going to move forward and forward and forward, its vertical component of the velocity. So what I will say, uh, v y, the vertical component, uh, initially is v naught y. It reduces to zero at maximum height. That is the maximum peak point when the projectile which will reach at maximum height. Okay, when it will reach at maximum height, its Vy will reduces to zero, but increases again in downward direction, increases changes its direction, downward direction, and so we can say here that Vy is decreasing to zero and again increasing in downward direction. So there is a vertical acceleration. So there is acceleration here vertically. So that acceleration, vertical acceleration, let me say ay, and if air is ignored, so this ay will be equal to g, that is 9.8 meter per square second. So if I try to sketch the same diagram, or I just go back to the previous slide. So here I will just say one thing, that when this was going down, so there was acceleration as well, and this acceleration was downward throughout the journey. So there are two component, ax and ay. So ax is 0, ay is there. So total acceleration, if I say what is the acceleration of this projectile, this acceleration is 9.8 and it is downward. If you say vertical acceleration, of course this is the vertical acceleration, it is always downward. So as object was moving upward in first half time period, it was velocity was considered as negative because it was slowing down and acceleration is downward. And when it is moving to the other half, so you can say its velocity is increasing, acceleration is downward, so it is a positive part of the acceleration and velocity. So here we are having two important things that we need to remember, that acceleration of the projectile is downward, and it's throughout downward, and also uh, downward and 9.8, whereas its velocity uh, uh, has two different things. I will just talk about it. So here we can say the acceleration of projectile is always projectile is 9.8 meter per square second throughout the journey, means in starting point till the end point, in the middle, in the quarter distance, in third quarters, or whatever it is, 9.8 meter per second, and it is always downward. Whereas vertical velocity is decreases to zero at maximum height and then increases to some other value at the maximum end point, and this is the scenario. Now, if I talk about the total velocity, let's say this is the same projectile. So it starts the motion from here till here. So what will be the total amount of velocity from the beginning? So total amount of velocity v, at any point, either it is peak or something. So its velocity v here at this point is v naught x square plus v naught y square, because two components, when you find their components and add, this is the way to find this one. So as this v naught y reduces, so v will be here less, but at this point there is no vertical component, so v is equal to v naught x square plus 0 whole square. So this v is equal to vx totally, and as it goes down, so it will start increasing again. So total velocity is also minimum here at this point. Velocity is minimum at this point because its vertical component is 0, and it's maximum at the starting point and before hitting. But if the object is going down, then you throw it from some building to up. So when it will be on the same level of building, its velocity will be the same. But as it approach downward, velocity vertically decreases, and it will go to zero. Here I would like to mention two important questions that we need to know about the projectile motion. So for the projectile motion, let me add a page here and try to just show you a question here, for example, that is also in the Giancoli book. And that question is related to uh, moving objects when it is moving horizontally or when it is moving vertically. So here, the first thing that we need to remember about this one is, let me try to copy the question, this one, and getting back to the point here, if I'm able to, yeah, I am able to paste it here. So this is the question. Let me make it bigger. If you are able to view the question, you can see this. There is an object that is red dot that is moving the projectile motion. So here, the first part is saying where in this figure 320 v is 0. So as you can see here, v, the total velocity is vx, vy, vx, vy. Here v is equal to vx. So it's not 0 here, not 0 here, not 0 here, not 0 here. So you can say in the first answer, where is the v0? Its v is never 0 throughout the journey. Yes, it is minimum here at the top because vy is 0, but it is never 0. Where vy is 0? So the second point, as you know, Vy is 0 at the maximum height at top of the parabolic path, and Vx is 0 throughout journey. No, we just said that Vx throughout the journey remains same. So Vx is constant throughout the journey. Whatever it was in the beginning, it will remain same in throughout the journey. There is a person who is holding a packet in his hand, and helicopter is going horizontally with uniform velocity. When helicopter is at position A, he drops the package from his hand, and when he drops the package from his hand, position of helicopter is A. Now, where this will package, uh, where what path this package will follow? So a is impossible, B is impossible because when he was holding the package, it was also moving with the helicopter. So horizontal velocity of the helicopter and package is there. When he dropped, there is an additional vertical component of velocity that make it to move down, but horizontal velocity is same. So as a helicopter is moving, horizontal velocity of the packet and the helicopter is same. So you can say this is the package. Horizontal velocity is Vx of the helicopter and Vx of the package same. So what will happen initially? Vy is 0. But after some time, this Vy will increase, Vx remains same. At some other point, Vy continue to increase, Vx remains same. So what will happen? This will follow this parabolic path that is mentioned in D, not C, not E, not A or B. So this is because horizontal velocity is the same. So this is what we call the projectile. So what I try to explain is the simple what is the projectile motion and how we can understand its motion. Thank you so much, guys.